Today we're going to be analyzing f of x given the graph of f prime of x. So in this particular example, we're going to be identifying the critical numbers or critical values when the function f is increasing or decreasing, the concavity of function f, and also where the relative extrema of our function f. But in this particular example, the graph that we are seeing is the graph of f prime of x. So let's go ahead and answer problem letter A. So in letter A, we need to identify and classify the x-coordinate of each critical value or critical number. Now, first thing that we can do, given the graph of f prime, is to label that everything above the x-axis is positive and everything below the x-axis is negative, and this will help us identify the behavior of the function as it increases and decreases and how the concavity works in our f prime graph. Now let's identify the critical value, and the critical value lies on the x-intercept of your f prime graph, and we can say that the critical value will be at x equal to -2, x equal to 0, and x equal to +2. And the reason why we have critical values at these values of x is because this is the reason why critical values can be found on the x-intercept given the f prime graph. Now, to be more specific, we're going to be looking at the relative extrema or the relative minimum, also known as the local minimum, and the local maximum of our function f given f prime of x, or the graph of f prime. So f has a relative maximum at x equal to -2, and the reason why it's at x equal to -2 is because f prime is changing from positive, so this is the positive value, to the negative value. So f has a relative maximum at x equal to -2 since f prime is changing from positive to negative. Now for relative minimum will happen at x equal to 0 because now our f prime is changing from negative, so this is a negative value, to the positive value of your f prime. So f and that's how we identify relative extrema using our f prime graph. Now for our third problem, we need to identify the intervals where the function f is increasing and decreasing. So it's pretty simple because the function f is increasing on the positive value of your f prime and it's decreasing on the negative value of your f prime graph. So to write the interval where it's increasing, right here on the positive interval. So since this is a closed interval and this is an endpoint right here, so we know that this function is between the closed interval -3 and +3. So we will use that in our intervals. So first, from -3 to -2, it's positive. -3 to -2. Closed interval, and from 0 up until 2, but it stayed positive up to 3. So we can say that's also increasing at 0 up until 3. closed interval, because this is an endpoint. And the reason behind this is because f is increasing this interval since f prime is positive. And it's decreasing on this interval. So this one is decreasing because it's at the bottom or below the x-axis, which is negative. So f is decreasing from -2 to 0. And the reason is because f prime is negative. And for letter D, we're going to identify where the concavity of our function f is. And to identify the concavity of the function, you will just look at the direction of your f prime graph. So here, it's decreasing or going down up until this point right here on x. So let's mark it. And then it starts to go up again here. And then here. So we have 4 intervals. So we know that it's concave up here and there. So that's when the function is concave up. And here. So we can say that f is concave up right here from -1 to +1 and from 2 to 3. Closed interval, and the reason is because in that interval. So concave down will be right here. So f is concave down between bracket -3, comma -1 and 2 and +3, since f prime has a positive slope. I mean negative, I'm sorry. Or decreasing on this interval. And the point of inflection, it's easy because the point of inflection is right here where the direction of your f prime is changing. So the POI is at x equal to -1, x equal to +1, and x equal to 2, since f prime is changing direction from increasing to decreasing and vice versa. So that is how we analyze our function f given the function f prime of x.